All right, we are recording. We're good.
Hey, thanks so much, Scott. Appreciate it. First and foremost, welcome everyone. I really appreciate everyone's time. Over the next hour or so, we're going to go through a field agenda, all pertaining to firepower. We'll focus on best practices, some recommendations, and optimization. My name is Paul Azzi, a cybersecurity CSC, working along with my colleagues that are our panelists here. I cover commercial accounts across the southern states. I've been in security for many years. I'll be quiet. Scott, Don, Jim, Ryan, if you guys can, in a few seconds, introduce yourself and let's kick things off. Let's go ahead with Scott first.
Yeah, my name's Scott Steyer. I'm a CSC. I'm a peer of each one of these panelists, and I cover, the Georgia region. I'm a commercial select, and I'm a chauffeur for Paul whenever he needs it.
That's funny. Hey, Don, go ahead next.
Don Fish, I'm a CSC. I cover Texas Select area as I work with the peers in this community.
Perfect. Thanks, Don. Jim?
Yeah, I'm Jim Gavane. I'm a CSE as well, and I cover the territory accounts in Georgia, Tennessee, North Carolina, South Carolina, and Florida.
Thanks, Jim. And last but not least, Ryan.
I am Ryan Firth. I cover the Mid-Texas Select commercial account.
Perfect. Thanks again, guys. Really appreciate your help. From today's agenda, I tried to break this down into some of the topics, but not exclusive to this. I'll be touching on quite a few additional components. From best practices, we'll look at variable sets, network discovery, security, intelligence. I'm going to spend a bit more time on the network discovery piece, and I'll show some key benefits to that. We'll review optimization, and to me, this is always about how do we get more performance out of our box. And we'll talk about some of the advanced settings on the access control policy tab. We'll review adaptive profiles, and we'll look at network analysis also. We'll spend a bit more time on the ACP advanced tab, to be candid. And when it comes to recommendations, really scheduling some tasks and some key things that we can do to tune. But you'll notice as we go through the optimization recommendation, some of the configurations and some of the parameters, they actually come from some of the best practices. So I would almost argue best practices should be called mandatory configurations, but there's nothing mandatory about this. Anyone who's seen my Friday Firepower Hour knows that I've got a pretty comprehensive set of gear that I work with in my lab. The last session, we migrated the 5506 to a 2110, so now I'm actually running a 2110 as my firewall in my network topology, but at the same time, I also do have a virtual FTD that segments the networks internally, and I am running 6.3 across all of my FMC and my Firepower instances. In today's lab demonstration, we're only going to be working with a subset of the different gear. So again, because a lot of these configurations are non-hardware, non-platform specific, whether I'm running virtual or an appliance really doesn't matter. It's going to be, regardless of the platform. But when we talk about adaptive profiles and some of the advanced tab configuration in the access control policy, that really does depend a little bit on the hardware that you're running, specifically if we have branch sites, remote sites, and I'll come back and I'll reference that as we go through. In my topology, I've got a domain controller that's running network services, and I've got a combination of Windows and Linux hosts that we're going to be using throughout the different demonstrations that we're going to be doing. With that, let me go ahead and jump into the UI, the interface. Let's start off with the first thing that I think is really a key component of Firepower, and that's the network discovery. So let's go to policies, and I'm going to go to network discovery. And I'm going to wait for this to load up, but as it's loading, let me quickly explain what network discovery is all about. There are application detectors in Snort, and as the traffic goes through the firewall, it passively, let me repeat, it passively identifies what that operating system is, what are the applications running, so on and so forth. And as it sees traffic going through from source to destination, it's able to understand that if I'm getting a response from the destination, then typically that's an open port, and that can be a server service as an example, right? So this is how it builds what we call a host profile. So my network discovery policy from out of the box, when you set up an FMC, this is going to be quad zeros, all 4 zeros. What that implies, it's going to discover each and every IP address. That may not be the best configuration, because if I'm going to go to Cisco.com or Microsoft.com, all those public IPs are also going to be put into this database, and it's going to learn and identify all the hosts that pertain to this IP address range. So what I've done is I've deleted the quad 0, which is every IP, and then added RFC 1918 addresses. Now, nothing stops me from coming in here to edit this and say, you know, I want to be specific. I only want to discover my homeland, my DMZ, my corp, my management, so on and so forth. So you can come in here and create objects and define objects. Now, the only downside for doing individual networks is if down the road you decide to add another network, you grow through acquisition, and you're going to be monitoring those networks as well, you got to remember to come back in here and to add these networks, where if you're doing RFC 1918, then that's going to pretty much encompass everything. On the downside is, if let's say we've got a development, a testing, a lab, and we don't necessarily want to include that network, let me show you what I can do. I can actually come here and add a rule, and in this rule, rather than having a discovery action, I can have an exclusion. So I can come in here and create an object that references an IP address or an IP subnet that I want to exclude from discovery. And so a good use cases may be a virtual IP, right, a VIP. Maybe I've got a load balancer and I've got services that sit behind it. I really don't care about discovering the virtual IP, nor do I really care about discovering the lab and so on and so forth, right? So there's a use case for doing exclusions, and that's some of these. But if I come back to my discovery rule, by default, if you do nothing, the only thing you're discovering are applications. It's useful, but not as useful as if I'm discovering the host as well. The user discovery, I'll tell you, it's a little useful, but not 100%, because this is, again, all passive. Passive implies that the traffic needs to be in clear text and needs to go through a firewall running firepower in order for me to identify the user. And then that helps in the context in not just simply looking at the IP address, but identifying who it is that's running that traffic alongside that IP address. So again, when we talk about best practices, you definitely don't want the quad 0. You want to have your internal range. You do want to have not just the application, but you want to have the host, optional users, as well as don't forget your exclusions. The other thing I'm actually going to point out from best practices is capturing banners, right? The default is we're not capturing banners, and what this is going to do is a lot of applications would have a banner like IIS or Exchange, and within that banner, more often than not, there's the version number, and that helps with the discovery for application versioning. So go ahead and enable this, and now I'm going to have a better fidelity in the determination of what is my application. Now, notice I've got a few additional settings that are different. The network discovery data storage settings, I've got mine set to 4 weeks. The default is 10,000 180 minutes, which is 7 days. Because my environment is half the time it's shut down, I don't want to do network discovery all the time, so I want to keep my endpoints, I want to keep the server services in my database for 4 weeks. So basically, if I don't spin up a VM after 4 weeks, or if FMC does not see traffic after the 40,320 minutes, it removes that IP or removes the server service or the application out of the host profile. So this helps 100% in giving me visibility into my network. So let's go to analysis, and I'm going to go to my hosts, and I'm going to go look at network map. And I'm going to show you some cool stuff based on this visibility that we're going to capture. So as this comes up to load, I want to reemphasize one important aspect. Everything that I've just showed you is done passively. And what do I mean by passive? Meaning that there's no widget installed. There's nothing that I'm configuring to scan the endpoints to see what's running. So passive implies I sit here like a sonar and I wait for things to come through. And when they come through, I'm going to try to qualify what it is. And if I see a little bit of traffic, I'm not going to be quite comprehensive in my discovery as much as if I see plenty of traffic. So let's look at the benefits of this network discovery, and I'm going to see a couple of, well, quite a few IP addresses. I've got 24 listed here. So let's go ahead and look at one of my Linux hosts. It's the 192.168.10.90. I'm going to let this expand and refresh. It should come back and tell me what is the operating system. It should come back and tell me any server services and open ports that are running on this. It's going to tell me any applications and protocols and so on and so forth. So let me stop here, right? So I can confirm that firepower, so this has been network discovery, it's firepower. It went through, it's seen some traffic, but not enough to identify what exactly this operating system is, and it's seen 13 different open ports. So what I've done is notice that on the upper corner I've got a scan host. So scan host uses the built-in NMAP tool that's in the FMC and all my firepower appliances or VMs, and I could leverage this to scan the host. So this would be an ad hoc scan. So what I've done to get this scan host button to light up is I went to my policies, I went to my actions, and I configured two things. The first thing I did was I configured a scanner. Under my scanner, I've configured an instance, an NMAP instance, and then I've defined the actual specific action that I wanted to have within that instance. So the first thing I'm going to do is create an NMAP instance, and I've done this. I've done quite a few. And then once you have an instance defined, I'm going to go in and create a remediation that we're going to use within that instance. And notice that I do have one called NMAP destination address or Friday Firepower scan source and destination. So you can configure these to be as aggressive as you want to scan UDP, TCP, or whatever that might be. But notice that these are the parameters for what you want this NMAP to scan. So I could configure this and have this run ad hoc, meaning I come in and I click and it's basically an on-demand scan, or I can configure this and integrate this with a correlation policy so that if a specific event happens, perform an NMAP scan as part of my remediation. So let me show you the benefit of being able to do this. If I come back to my 10.90, it's a NAT device, no current user, operating system. It's one of these 13 server ports open. I'm going to click on the scan host. The NMAP remediations that I had are all listed here. I'm going to go ahead and do a scan. It should accept that command, and it'll take maybe a minute or so to run. There we go. It's been queued in my tasks. So if I go to my task, we should see that my NMAP is running. So we'll let this run and we'll come back to it. But that's part of the integration of a passive scan, and this would be what we refer to as an active scan. So we can integrate both, and we can configure under my policy, my discovery policy, if there's a conflict between the active scan versus the passive scan, who has priority, right? So who would have priority? And I'll come back to my network discovery and I'll show you what that setting is under the advanced tab. And I'll bet you this should almost be done. If not, it'll be pretty close to being done. There we go. It ran on 10.90. It took 52 seconds. Let me reload and refresh this page. Now, while this is refreshing, let's come back to my, let me close this NMAP. Let's come back and look at our network discovery under the advanced tab. And here's where we have a conflict. So an identity conflict by default is disabled. When I enable this, it's going to give me a graphical representation of the active results and the passive result. Example, it sees that port 80 is open. Maybe passive discovery thinks it's IIS 7.0. NMAP ran, it's IIS 7.5. Which information do I want to keep in the host profile for that specific IP address? I could say, keep the active or keep the passive. The fact that I say disabled means I need to come in as the admin and pick and choose which one do I want to keep. And I keep this for demonstration purpose. More often than not, people will keep the active because it's better fidelity than the passive. So let me come back to my network discovery. Let's go back and look at that 192.168.10.90, and hopefully something's changed on that endpoint. So let's wait for this to refresh. I know we're spending quite a bit of time on the network discovery, but there's really a lot of benefit when we talk about this. And we'll see this a little bit more in our intrusion policy recommendations. We'll see this under the advanced tab of our access control policy. And again, now we just went from 4 different operating systems to notice that the scanner is the source. NMAP scanned, and now the fidelity is, this is 2.6. And the different servers, I think we have 13. So it did not see any new servers or open ports, but I can't recall if it defined the application versioning specifically or not. But that's one example of how we can run a active scan in conjunction with the passive scan. With that, I'm going to shift gears, and I'm going to go start looking at my variable set. So this is under my objects. The reason I really focus on variable sets is if you think about an intrusion rule, it always has a source and destination IP address. And when we're getting these snort rules from Cisco, they use variable sets, or variables to be specific. So the source could be any destination, could be our HTTP servers. The source could be from the outside, which is called the external net, coming to the inside, which is the home net. So if I go look at my variable sets, a variable set is essentially a collection of several variables, and these variables have values. So if I come in and look at my external network, it's set to any IP address. If I look at my home net, it's set to any IP address. So if you don't do anything and you leave your variable set at any to any, each and every packet traversing your firewall that matches a rule that has an intrusion policy and has a variable set that has any to any, that means I'm scanning each and every packet to determine if it hits a snort rule. That is a needless use of CPU, needless use of resources on your firewall. So at a minimum, you always want to come in here and define what is your home net. And my home net is this is where you got to understand where your firewalls are, where you're doing intrusion policies, and so on and so forth. So there's a couple of ways to do this. You can say my networks are RFC 1918, so maybe any IPv4 address, but that's not really good because that's any IPv4. Let me find the RFC 1918 addresses. So here's the different RFC 1918 addresses. We can go ahead and include these if we wanted to, you know, 1, 2, or all 3, depending on what we're running. But and again, what this is doing is saying anything that is destined to these network then trigger. If you think about it, if I've got a data center firewall that's running IPS, or even just an IPS inline with inline sets, both sides of the network are going to be RFC 1918 addresses. So always think about what are you protecting? What are the application networks? What are your data center networks? And then you're going to be real specific for the variable set that is protecting those assets. So if my DMZ happens to be the 10.10.5.0/24, then create an object. Go ahead and create an object, call it my DMZ network, and go in and type in the IP address, the 10.10.5.0/24, and use that as your home net, and then your external net would be anything that has not been defined. So if we go look at my external net, what I want to do is then exclude my home net. So that means anything except for my, you know, DMZ network in this example, go into my DMZ, let's inspect it to make sure there's nothing malicious in that traffic. So that's a great way to help reduce false positives, but it also improves performance because we're not cracking open each and every packet, looking at the source and destination layer 3 address and having to pass this on to Snort for further analysis, for further inspection. So that is a great way to optimize performance by defining accurate values in variable sets. And you can have multiple variable sets configured, and you can use these in conjunction with intrusion policies on a per rule basis or on a per access control policy basis. It's pretty flexible how we can deploy the variable sets. Now, once upon a time, the values of your variable sets were integrated directly into an intrusion policy. This is going back to the SourceFire 5.2 in older days where the variable sets were embedded right in the intrusion policy. The downside is that intrusion policy, if it was used in multiple sensors, then that variable set either had to be really comprehensive to include all the networks, or we had to clone that intrusion policy and have multiple instances and then have a granular variable set on a per policy basis. Well, now that in 5.3 and current, that variable set has been decoupled from the intrusion policy, so now we can create variable sets independently from intrusion policies and then group them together in an access control policy. I want to come back and talk about network discovery, but I will do that in a few minutes when we come back and looking at some of the benefits from this. But before we shift away, I'm going to scroll down a little bit, and what I'm going to point out is we're going to see mapped vulnerabilities that pertain to the different operating systems and applications that it's in. Now, this does not imply that these are 100% applicable because, again, this is passively discovered. So there's no way for Firepower to know if the host has been patched. It is not doing an authenticated vulnerability scan. So this is passively sitting there like a sonar and waiting for the traffic to come to it, and then based on the application detector, it's going to come back and say, here's what I think you're vulnerable for. So the fidelity isn't great, but it's a great starting point. So you certainly can run your own vulnerability scanners, and using the host API, integrate the results from your scanner into the Firepower Management Center, and then that is the same thing as that network discovery identity conflict setting, where you can automate an active scan to have this information be ingested by the FMC, and you certainly would want it to overwrite because you have better fidelity with an active scan. So let's shift gears and let's go look at the security intelligence. And again, this is essentially my first line of defense. Let me get to the security intelligence, network lists and feeds. And again, this is derived from Cisco. These IP addresses as well as domain names and URLs come from Cisco. They are updated on a regular basis. When I say regular, I can shrink this down to every 5 minutes. And from a domain name and URL, I can shrink this down to as little as 30 minutes. Now, the fact that these are being downloaded does not necessarily imply that they are going to be used. So this is configurable on a per access control policy basis, meaning that if I download them and I've got the following access control policies, let's wait for this to load. If I go ahead and edit my virtual FTD access control policy, I'm going to wait for this to edit and open up in edit mode. And I'm going to click on that security intelligence tab. There we go. The fact that I've done this, and you can notice that I've already captured the network and URL block-listed objects, but I'm actually using this in this policy. So the fact that I've come down here and I said, let's pick crypto mining and command and control and bots and attackers and pretty much everything else, and I've added to my blacklist, the fact that I've done this and the same thing for my URLs implies that when this policy is assigned to this specific firewall or this specific sensor, that means that this firewall or this sensor is enforcing blocking of these objects, blocking these IPs and so on. The other firewalls are not. So that would imply that I would have to go back and look at my other policies and make sure that they're doing the same thing. Let me go ahead and create a new access control policy. I'm going to call this my Friday Firepower Hour demo ACP, and I'm going to have this apply to my 2110 as an example. I want my default action to be IPS. If this is Internet, I'm going to have it as block traffic. I'm going to save this. And it says, wait, you already have an Internet edge policy. Do you want to override? I'm going to say, yeah, let's override it. That's fine. Now, keep in mind, nothing takes effect until I deploy. So I can create this to my heart's content and play with this, but until I come up and I deploy this policy, nothing takes effect. But the goal from this exercise is to come to my security intelligence tab and notice that they're all listed here, right? So these are all the network objects that I've created, that I've downloaded from Talos, but they're not in use, right? They're not in use. And the same thing with my URL objects, they equally also are not in use. So if I hover over this, I can see I've got, close to 300,000 URLs, but I'm not blocking. So this is a manual configuration on a per access control policy basis. So let's come back and start looking at the advanced tab of this access control policy since we are within the access control policy. This can be quite intimidating if you don't know what these settings mean. And my goal isn't really to spend the next 30 minutes going through all these settings. But what I want to talk about is a couple of key things to understand what these do for me. So I want to talk really about the detection enhancement settings. Look at the word detection enhancement. So that implies as the traffic goes through the firewall, we want to identify the threat a little bit better. And how can we identify the threat a little bit better? Well, if I go ahead and edit this, notice that it is enabled by default. Once upon a time in 5X, you had to turn this on. And in other versions, it was enabled, but don't take it for granted. Always come up and check. And I'll tell you what this does. So if we're doing network discovery, and in here I can identify the different applications running on the endpoints and the versioning of these applications and the operating system, when the traffic going through the firewall is destined for an IIS or versus an Apache, as an example, if there's any type of reassembly that takes place, it's going to reassemble the traffic and analyze it as if the target operating system or the target application would. So what this does, it improves the efficacy of the detection based on how the target is. So if I come back and look at my network discovery, so there is a 100% correlation between having a more comprehensive and better network discovery and improving the fidelity of detection threats destined to the different applications. So here's where we can improve and optimize performance. If we do an enable profile updates, what this implies is go look at my network discovery, and if I'm putting quad zeros, it implies come in here and look at each and every single IP address, which is not a bad thing because you want to look at each and every IP address. And then I want you to go look and refresh this by default every 60 minutes. Now let's think about this. If I've got 40,000 IP addresses or 20,000 IP addresses or 100,000 IP addresses listed here, it's going to capture the application and the operating system. And where do you think it stores that information until the next update refresh cycle? If you're thinking it's going to put that in memory, you're absolutely right. It stores this information in RAM. So if you've got a branch office and you're going to have a separate access control policy for that branch office, come in here and say, you know what, I don't want you to look at my 10,000 IP addresses. I want you to be specific to the IP addresses in that network. So what this does when you do this, it tells the firewall to come and look at all the IP addresses in that network, in that range, and to put this information, specifically this information in RAM, and then to refresh this. Well, maybe I don't have great bandwidth between my branch office and my firepower management center, so maybe I want this to refresh every 4 hours, so I'm going to change this from 60 to 240. There is nothing that documents the best practices from 60 minutes to 120 to 240. That really depends on your network bandwidth, the available bandwidth, your utilization, so on and so forth, right? And the second thing is, if you've got 2 subnets at that remote network, you put a comma and you go ahead and add the second network address at that site. So now it's actually going to query both subnets. Now I don't have a .40 here, but for example, let's assume that there is a 40. So now it's going to come in here and do the both network addresses and update the firewall based on this refresh interval. And what this does is improves fidelity, but at the same time, because I'm not leaving the quad 4 zeros here, the quad zeros, it's not looking at the entire network discovery host profile, so therefore it's not going to overrun the utilization of memory on that remote box. Now I say this, if you had a 2100, you know, and you've got a 200 meg pipe, and you've got, you know, maybe a couple hundred users, you know, 500-600 users, utilization on the box is really, really small. maybe you leave it at quad zeros. It doesn't impact you. If you're running a 5506, 5508, 5516, it's pretty maxed out. You're trying to save a little bit of performance at each and everywhere that you can. That might be one of those cases where it's going to help you in tuning that firewall specifically for that one site, if that makes sense. Second thing I want to talk about is file and malware settings. This kind of ties directly in conjunction with that branch office I was talking about. So if we understand the workflow, when a file comes in, the firewall, based on the file and malware policy, if we're doing a malware cloud lookup, it's going to buffer the file locally, meaning that as the packets go through, it reassembles the file. Once it has the complete file, it does a SHA-256 hash calculation. It looks at its local cache for the file. If it doesn't find it, it queries the FMC, and then the FMC is responsible to send the SHA out to the AMP cloud to get a disposition. And it comes back with a disposition. The FMC caches that and then passes the results to the remote firewall. And if it comes back with an unknown, meaning I've never seen the file before, the file is submitted from the local firewall. So that means the file being uploaded, if we're doing dynamic analysis, by my firewall. So these different parameters here all pertain to how do we want to handle traffic based on this specific access control policy. So notice that the default is 2 seconds. So if you don't get a disposition back within X number of seconds, let go of the last packet and let the file go to the destination. This is a classic example of performance over security. If security is more important, or if this office really has a branch office, the connectivity to the FMC is real slow, I've got a lot of latency. So remember, the SHA request goes to the FMC, FMC goes to the AMP cloud, I get a response back from the cloud to the FMC, which in turn goes back to my branch firewall. So this is where you can control that timeout before you let the file go to the destination. As you increase the value, you're introducing more latency on the network because you're holding up that file until you can get a disposition, right? So it boils down to, do I have the bandwidth I need to support this? Yes, perfect. If I don't, then do I care more about getting the file downloaded in a timely fashion, or do I can I tolerate introduced latency? The same thing, if I want to go ahead and send the file to the threat grid for file behavior analytics, what is the minimum and maximum file size that the firewall can submit? So if you're downloading files that are smaller or greater than these defined in this access control policy, you may be thinking all files are being submitted, but no, you've got control over the minimum and maximum file size. And the reason I mention this, again, if I've got a branch office and that branch office has a 1 meg pipe to the internet, and I'm going to modify this to go up to 25 megs as the file I'm going to upload, you got to realize that that's going to choke that network while that file is being uploaded to threat grid. So if you've got some branch offices that have ample bandwidth, maybe you can bump this up, the value of the file that you want to submit. If you're struggling with bandwidth and performance is more important than security, then maybe leave it as is, but you know that you can modify this. And the last thing to call out is we can store files locally. So let's say I want to store the file to do my own analysis, and again, there's a minimum and a maximum file size that will be stored on my firewalls. And then, so this is again showing you the place where you would modify this, and again, this is on a per access control policy. So if you've got, maybe a pair of internet-facing firewalls, then you've got 5, 6, 20, 25 branch offices, and each one has their own firewall, and you're using the same access control policy for, my internet-facing firewalls at HQ and all my branch offices. The settings that I do here will be inherited by each and every firewall. So this, in conjunction with the adaptive profiles, might be a reason of where you want to have separate access control policies for specific branch offices that maybe we don't have ample bandwidth, right? So let's shift gears, and I really want to talk about network analysis. So we did the adaptive profile to have better fidelity, right? Because I need to understand the target so that I could emulate how the target would reassemble handling of the packets as they come in, so we understand if there's a threat for that specific endpoint. Well, network analysis policy does similar things. So if I come and look at my network analysis policy, and I can access this in 3 different ways. This is just one way for me to get there. There's a very similar to intrusion policy. You're going to have the connectivity over security, security over connectivity and balance. And really, this is tuning the aggressiveness of how that inspection or the detection will take place. So let me do this real quickly. I'm going to create a policy, and I'm going to call this my Friday Firepower Hour _ demo. And I'm going to go ahead and pick my connectivity over security. Let's go ahead and create and edit this policy. And I'm going to show you the big difference between one base policy layer versus the other. Unlike intrusion intrusion policies that essentially we're turning on more rules as we get into more security base layers, this is tuning the aggressive handling and inspection of packets, not necessarily turning on more rules. It's just making the detectors more aggressive in how we handle the traffic. I'm going to pick HTTP as an example, and again, we can see there's about 11, 12 ports that are open. We're not scanning. We're not looking at maximum header length. We're not looking at maximum number of headers. If I scroll down, there's no alerts with this. We're not normalizing HTTP headers. We're not inspecting HTTP cookies. We're not inspecting HTTP responses. We're not inspecting compressed data. Why? Well, because it's not as aggressive as if we went to a security over connectivity. And if I come up here and I say, okay, so let's change this from connectivity over security to security over connectivity, and let this refresh, and I'll come back and look at that same HTTP configuration, and you'll notice that I went from 11, 12 ports to substantially much more port, somewhere in the 50 to 60 range. And if I scroll down, we start looking at the client flow depth, server flow depth. Earlier it was 300. Now it's 0, which means there's no specific limits. Keep looking all the way through. And if I scroll down, we are normalizing HTTP headers. We are inspecting cookies. We are inspecting responses. We are inspecting compressed data, which means you've got to decompress, inspect it, and then recompress it. That is putting performance hit on your firewall. If your firewall is, again, a 2100, high-end 2100, 4100, 9300, and performance is not an issue, but you care more about security, maybe you go to security for connectivity. If you've got a smaller 5500X at a branch site and performance is an issue, then this is where you can come in here and say, you know what, maybe I don't need to be overly secure. Maybe the aggressiveness of a balance somewhere between might be spot on for me, right? So this is where you can leverage. And by the way, you can have a NAP policy on a per network. So if I come in here and I look at my custom rules under network analysis, I can come in here and say, go into my specific DMZ. I want you to be more aggressive than maybe my HQ traffic, right? So I can come in here and say, well, go into this specific network, come into my DMZ, add to destination. I want to use this specific security over connectivity, and then I'm going to go ahead and add this. And now I'm going to add another rule, maybe go into my I don't know, corporate network instead of the DMZ, and say for that one, let's go to corporate, add that as destination, and for this, it's going to be balanced. There we go. Let's go ahead and add this. Notice that I've come in here and I've tailored the network analysis policy based on a destination. But I could use zones as a source and destination, networks as a destination and a source as well, or based on a VLAN tag. Enough with this. Let's jump to some of the recommendations. I'm going to come back and look at this network discovery. So we understand we've done network discovery. We've got visibility to the OS, the open ports, applications, protocols, and then we're going to map known vulnerabilities to this specific IP address. And we do this for each and every IP. So I've got 10,000, 20,000, 30,000 IP addresses. So what we're going to do is go look at our firepower intrusion policy. So let's go to my intrusion policy. I'm going to cancel this. We don't care about saving these changes. And I'm going to come up and look at a couple key things. And while this is loading, let me come here and go look at my system and go look at my updates. So I think it's important to identify some key things, guys. And a lot of people don't acknowledge that intrusion rules are defined by the Talos organization at Cisco, and they push out snort rule updates with regular cadence, several times a week, up to 10 times a month. So I think it's important to come from a rule update perspective. As new vulnerabilities are discovered and new snort rules are created, we do want to download these. So I think it is best practice to enable recurring rule updates when it comes from Talos. And I've set mine up to download on a regular daily basis. Now, this is an optional configuration. Deploy updated policies to targeted devices after a rule update completes. So that means download, and when it downloads, go ahead and deploy it so it takes effect on all my firewalls. The challenge with that is maybe you don't want to deploy it right away until you go through and you vet some of the rules to make sure nothing will break in your environment. So I've got a dedicated team. They come in, they look at the intrusion rules, they validate that we do need them, turn them on, and then push out the policy based on my schedule, right? On the flip side, maybe we're lean IT. I wear, several hats. I don't have time to vet all the rules. So, you know what? If Cisco says these new snort rules are good and Talos wrote them, I'm good with it. So let's go ahead and deploy them. But the key takeaway from what I'm trying to get at is make sure at a minimum that you are downloading these new snort rule updates. If you're not, then you are as protected as the latest rule set that you've downloaded. Now, that's one part of the equation, right? So downloading is part of it, and obviously deploying it is the second part. And that you can decouple this process and vet in between, validate, and then deploy. Now, the other thing that's really important to understand is when I go look at my intrusion policy, I'm going to go ahead and create an intrusion policy. I'm going to call this the Friday Firepower Hour. IPS demo. My bad, I think this is under my NMAP policy, so let me go to my intrusion policies. So let me come in here to add intrusion. I'm going to create an intrusion policy. I'm going to call this my Friday Firepower Hour, IPS demo. And again, I really don't care too much about the base policy layer at this point. The goal is to show you the intrusion policy recommendations. I think a lot of people are aware with the intrusion policy recommendations, but these recommendations, they tie into two key components. And this is where I want to show you that it relies on vulnerabilities found here for each and every one. So now you can start seeing that having a better network discovery is really key to identify specific operating systems and applications, right? And the second thing is being able to integrate with some kind of vulnerability scanner to actually have the fidelity of what vulnerabilities exist on the endpoint. So both of these in conjunction will give you better rule recommendations. The second thing is having an up-to-date SNORT rule set is the second requirement. But the third one is this vulnerability that we're looking at, this vulnerability is downloaded through what we call the vulnerability database, the VDB. So if I come in here and I look at my product updates, you'll notice that there is a VDB that gets downloaded, but it does not get installed. So that means you have to install this. So this VDB is a vulnerability database that has operating system and application fingerprint so that we can identify new applications, but at the same time, it's got the vulnerability database. Notice that it does not require a reboot, but I'll come back and show you best practice what we do with this. So let's come back here to my intrusion policy as this expands and loads. There is a firepower recommendation section. So from here, I could come in and generate and use the recommendations, or just simply generate and let me review them. And under the Advanced tab, if this intrusion policy is for my branch office, go in and do recommendations for that specific branch office. No sense in looking at my 10,000, 20,000, 30,000 IP addresses in my host profiles. Look at them specifically under the host profiles for that specific subnet, right? So this gives you fewer recommendations, improving performance without and reducing false positives, right? And the second thing to call out is we talked about having not only the rule set, the SNORT rule set up to date, but the vulnerability database. So if I go look at my system, tools, scheduling, I'm going to go ahead and schedule my vulnerability database to be pulled down on a regular basis, but I want to install this vulnerability database with regular cadence as well, right? So notice that I've configured mine to download once a week on the Saturday. Now, this VDB typically comes out every 6 to 8 weeks, maybe a little bit longer, but the point is there's no harm in trying to download it every week as opposed to trying to download every month, because if I try to scan to download this maybe the day before it releases, then I've got to wait 3 weeks and, 3 weeks, 6 days before I try again. And at that point in time, I don't have an up-to-date list of vulnerabilities. So when I create an add task, there's 2 steps that I recommend doing. One is to download the vulnerability database, and the second task is to install that vulnerability database. So I'm going to come in here and I'm going to say, let's go ahead and do that download latest update. I'm going to wait for this to refresh. It's going to ask me what update do you want to download, and I'm going to go ahead and let it know which one I want. So I want this to be recurring, and I want the vulnerability database, or maybe I want both to download on regular cadence. But if I'm doing this every week, I typically want my vulnerability database, and based on the recurring job, I give this job a name, and I specify when I want this to run, and then it runs based on that cadence. So in my case, I say run it every week on Saturdays at whatever time I want this to run, and I let it run. And the second thing I would recommend is install this latest update. So again, let it refresh, and we'll wait for this to come up, and I'll go ahead and pick the FMC. As it refreshes, perfect, right? So now install the latest update, and if I pick my FMC it's the vulnerability database that we're going to be updating to that FMC. If I try to pick my 2110, really, if you gave this time to refresh, you're not applying the vulnerability database to your 2110. That's all exclusively installed on my FMC. Here we go, right? And then again, in my case, I schedule this to run on a weekly basis. So now I've got better network discovery. I'm going to have up-to-date snort rules. I've got up-to-date vulnerability database. So using all three in conjunction, when I run my firepower recommendations, I'm going to have a better, accurate rule set that's going to be specific, tailored for my environment based on those conditions, right? That's an important thing to address. And another benefit, and I know we're top of the hour. I just need 5 more minutes, and we'll wrap things up in 5 minutes. But the cool stuff is, now that I know what's wrong on my network, I'm going to give you a use case. Let's say I've got a server, I've got a DMZ, I've got a specific network, and on that network there should be no RDP, there should be no telnet, there should be, how would you know if someone is launching an application over one of those networks, those subnets, without some kind of a monitoring tool, right? So Firepower can do this for me through what we call a whitelist. So let's go to my correlation, and I'll show you what I'm talking about. So as I go to my correlation, let me do this real quick. I'm going to go to my whitelist, and what I'm going to do is I create a whitelist that says, and this is not like whitelisting a file or whitelisting an IP. This is more along the line of what is acceptable, what is permissible on that specific IP or subnet. So if I come in here and I say, give me a new whitelist, and I'm going to pick a specific starting point, a subnet or an IP address, and from there, it captures all the information that it sees on that specific subnet. So if I say, let's start off with my DMZ, 192.168.10.0/24. If I do add and survey network, it goes and looks at all the operating systems that it has discovered on that network. And then if I pick Windows 7, here's all the different open ports that I've seen. So I'm going to go ahead and jettison RDP. RDP should not be on this network. So I'm going to go ahead and give this a name. I'm going to call this my Friday Firepower Hour whitelist_demo. So again, all these OSs are good. I click here. I don't have RDP. I don't have RDP for any Windows. Let's go ahead and save this whitelist. Now what I'm going to do is go into my correlation policy and say, well, when this whitelist triggers, because I'm going to see an OS, or I'm going to see applications, or I'm going to see allowed clients or protocols that are outside of what I've defined as being permissible or accessible, I want you to go ahead and fire a response based on whatever associate from my remediation in conjunction with this specific whitelist. So this has been saved. Let's go to my policy. And by the way, guys, you know, we're doing this in 1 hour. There's a lot of information to cover in 1 hour. The good news is it will be saved on, it'll be uploaded and saved and available on YouTube, so you guys can go back, rewind, replay, and so on and so forth. So let's go ahead and create a policy, and I'm going to go ahead and pick that whitelist. Then I'm going to associate a response. So this is an example of, I can integrate this with built-in remediation instances that are built into Firepower, like ICE integration with PXGrid, doing an NMAP scan, setting an attribute, or you can integrate this with other different devices. Oops, let me go ahead and add the policy. There we go. Here's that Friday Firepower Hour whitelist demo. I'm going to add this, and then I'm going to associate a response to that rule, to this whitelist, so that when this triggers, go ahead and perform a response. So a response could be a simple email, it could be a syslog, it could be an actionable item as well. So to specify a response, you click on this icon, and in my case, I'm going to perform a scan. Maybe I want to email the team. I'm trying to read this real quick. Where is the email? There we go. Notify security team, and I want to go ahead and do an NMAP scan. Let's add that update, and I'm going to save. Now, correlation policy, when you save it, it does not take effect until you activate it. So as soon as this goes ahead and it gets activated, I'm going to go ahead and try to RDP from one host to another through my firewall, and we'll see if this actually takes effect. Oh, did not give it a name. Friday Firepower Hour. I'm going to call this my correlation demo. And as soon as this saves, I'll go ahead and activate it. Then I'll run my RDP from one host to another, and we'll see what happens. While this is running, to save, I'm going to go ahead and close this. I'm going to go ahead and discard. And let's come back to our correlation. Now it's been saved. So here is that Friday Firepower correlation demo. I'm going to have to click once on this slider bar, and what this is going to do is take it from a disabled to an enabled state, and we'll know when it's enabled when we get a green check, and we can see the cogwheel spinning on top to say it's refreshing, it's trying. So now let's go ahead and kill this, and we'll give it a few more seconds to be active. It's now activated. So let's jump into our VM. So I'm going to come in here, and what I want to do is target this host. Let me do a couple things. Let me do an IP config on this host. So this is the 133.10, and let me look at this specific host. Command prompt, IP config. This is 10.230. Let me see who am I logged in as right now. Who am I? I'm logged in as a VP user. Good. So let's come back here, and I'm going to open up a remote desktop session, MSTSC, and I'm going to go to 192.168.10.230, and I'm going to collect as sfsnort, that's my domain name, VP user, and let's type my password. Close your eyes when I type my password, if you guys don't mind. I'm going to say yes, not authorized for remote login. So maybe he doesn't have administrative rights. So let me log in as the administrator, sfsnort/administrator, password, and say yes. Another user's logged in. Yeah, let's kick him off. So now VP user gets disconnected. I'll be disconnected in 30 seconds. Let's say, okay, kick me off. So now the point behind this is not to demonstrate remote desktop, because I think we're pretty good with that, but it's to come back here and look at a couple of things. So I'm going to go under my analysis. I'm going to go look at my hosts, network map. So this is that network discovery we were talking about. And I should see RDP being added to the 192.168.10.230 host, number one. And number two, I should have initiated an NMAP scan on that endpoint. So let's come in here, and look at the 192.168.10.230. And the reason I'm showing this, guys, is to really show the benefit of that network discovery. And this is one example of a whitelist looking at a new service. But think of this from a security perspective, some of the ramifications of not seeing all the traffic and having visibility, at a minimum being notified when something changes on the network. So let's click on 10.230. Give it a second while this is loading. I'm going to actually come up here and click on tasks and see if anything has initiated. Not seeing that being initiated yet. There we go, RDP, here it is. Notice this little bolded exclamation point. It violates my whitelist. So I'm saying there should be no RDP sessions on this network. And if I scroll down, I'm going to see a whitelist violation. And here's the whitelist that it hit, and here's the port that it saw. And if I go look under my analysis, under my correlation, under my whitelist violations, I should see this. And if I go under status afterwards, I should see the NMAP running if everything works as expected. And again, I'm trying to rush through here because I know I'm past the top of the hour. While we're waiting, any questions, Scott, Don, Jim?
Like always, you explain and articulate so well, there's no question.
Perfect. And again, because I use my 192.168.10 network as for my whitelist, all the IPs in here that have RDP defined, I actually see them. Here's that 10.30. If I drill into him, it'll take me right back to the host profile of that host. And let me come back and look at the status, analysis, correlation, whitelist status. And we should see the, again, if the NMAP brand, we should be able to see that. And the other places I can come in here to my scanners, let me open this up in a new tab, and show you that we can see results of scans from here as well. So every time you run a scan, you should see it from your scanner tab. So here it is. We saw the address, we saw the RDP, we saw the whitelist that it hit, and this takes me to the host profile. Let's come up here, and I could look at the scan results in the upper corner under my policies, actions, and scanners. And while that's running, here we go. No, these are all old stuff, so nothing triggered for whatever reason from a correlation perspective. So I doubt that we're going to see the scan take place here for 10.230. Yep, we did did not trigger. So I mean, I can go back and debug that. Maybe I ran the RDP and the actual correlation policy had not saved properly. But in any case, the net is that we saw how to integrate that, and we got a whitelist violation. We can see that in the host profile. With that, I'll be quiet. So let's see if there's any questions, comments before we call it a day. And by the way, guys, I'm thinking for my next Friday Firepower Hour, doing an introduction to snort rules, so understand the construct of a snort rule, how to understand what the rule is trying to do, and possibly even understanding how to write our own snort rule. Again, not becoming proficient, but more of an introduction to snort. If you guys think that's a useful topic, let us know. Everyone is really interested in hearing what you guys would like to see, and we will be more than happy to deliver based on your needs. With that, let me be quiet and see if there's any comments or questions. Well, if there's nothing to bring up, anyone needs to be unmuted for anything to bring up, to ask, as opposed to typing it in.
Hey, Paul, one of the guys looks like he's asking, says, any plan to explore SSL decryption?
Yeah, we can certainly do that. That'd be a great session to work around. Now that I've got a 2100, we can certainly look into doing an SSL policy. Absolutely. Great feedback.
Other than that, that's it. That's all we got so far.
Perfect. Well, hey, guys, it is Friday. Happy Friday for everyone. Have a great weekend. As always, we appreciate you guys. And until next time, thank you.
All right. Thanks, Paul. Appreciate it, guys. Take care.
Scott, Don, Jim, you guys rock, man. Appreciate y'all being here.
All right. See ya. Have a good weekend.
All right.
You too.